In this session, we will analyze how to build several components for a PCB enclosure. The acronym PCB stands for Printed Circuit Board. Many consumer electronics use printed circuit boards, and they often must be assembled in some type of enclosure. The enclosure contains other important items such as fans, heat sinks, and sometimes buttons and connectors to allow the user to interact with the electronics inside. In this exercise, we're going to create a few components for the PCB and modify the enclosure to allow for adequate ventilation.
We'll start by creating 3 different size capacitors and placing them on the circuit board. This may sound time-consuming, but don't worry, we've got a great way to make this quick and easy. After that, we'll improve the design of the PCB enclosure by adding holes for ventilation. To increase airflow over the circuit board, some fans will be required, so we'll also be placing some mounting holes and creating cutouts for the fans. We'll then design the fan housings and assemble them. Lastly, we'll assemble a heatsink and quickly alter the geometry to match existing components on the PCB.
Let's examine the assembly to get an idea of how we can make the necessary changes. Open the file labeled PCB exercise file. Look at the main model and rotate it around a bit, and note that the enclosure, which is the box that contains all of the circuitry, has no holes for ventilation. In the finished design, there would be a lid covering the top of the enclosure, so the current design isn't great. Press Ctrl 2 to orient the model in the front view. The circuit board looks a little bit empty. Our first task is going to be to create some electrical components to add to the circuit board. Refer to Sheet 2 of the technical drawing. This drawing contains the dimensions to create a capacitor. A capacitor is a device that stores electrical energy in an electric field, usually in the gap between metal plates.
If we examine the technical drawing, we can see that our capacitor doesn't have any internal structure, so we can think of it as being for display purposes only. This model is essentially a cylinder with a few minor modifications. It's generally advisable to create the bulk of a design in the first few operations, then add the finer details. Keeping that approach in mind, we can begin by creating the main cylinder. The groove near the base of the cylinder can be created with a revolved cut. Then, we'll add the depressions on the top and bottom faces and create the radius along the top circumference. The last step will be to add the 2 pins on the bottom of the capacitor.
To begin creating the capacitor, create a new sketch anywhere in the PCB exercise file. The orientation of the sketch is not important right now. The front face of the enclosure is a good place to start. Create a rectangle 25 mm high by 10 mm wide. Start the Pull tool and select the rectangular surface. Click the Revolve option and select one of the long edges of the rectangle as the axis to rotate about. Then press Enter. This operation should create a cylinder with a diameter of 20 mm and a height of 25 mm. Move the mouse cursor over the cylinder and select the dashed center axis. Then create a sketch. The sketch plane should pass through the center of the cylinder. Select the Circle Sketch tool. Then move the mouse cursor to one of the bottom corners of the cylinder and tap the Shift key. Place a circle with the center point 4 mm up from the bottom and 1 mm outside the cylinder. Set the diameter to 4 mm. Start the Pull tool and select the circular face. Select the Revolve tool again and select the same axis of the cylinder. This time, select Cut from the Pull options on the left side of the window and click Full Pull to cut a groove around the base of the cylinder. Click anywhere in the background to revert to the basic pull function. Then hold Ctrl and select the top and bottom edges of the groove. Use the Pull tool to apply a 1 mm radius. Press S on the keyboard to exit the Pull tool. Create a new sketch on the top face of the cylinder. Sketch a circle with a diameter of 16 millimeters. Place the center point at the center of the circular face. Repeat this process on the bottom face of the cylinder and use the pull tool to create a 1 millimeter depression on each face. Hold Ctrl and select the two edges at the top of the cylinder. Use the pull tool to create a full round. You can create a full round by clicking and dragging slightly to begin adding a radius, and then moving the mouse in the opposite direction. If done correctly, the two edges should be rounded into one continuous arc. Now, we need to create the pins at the bottom of the capacitor. On the bottom face of the cylinder, sketch two circles, each with a 2 millimeter diameter. Place one circle 5 millimeters up from the center and the other circle 5 millimeters down. Pull both profiles 5 millimeters to extend them and create the pins. We're now going to duplicate the solid body using Move Copy. Start the Move tool and select the body. Then hold Ctrl and click and drag the Move tool in any direction. Click and drag again to create a second duplicate. The completed assembly has 3 different size capacitors. We can create these quickly using the Scale option within the Pull tool. Click Pull and select the Scale Body option. Locate the world origin and select it as the anchor point. This is a point that will remain fixed as the rest of the body is scaled larger or smaller. Click and drag a box around the second capacitor. Enter 0.75 as the scaling factor. This new capacitor is 25% smaller than the original. Notice how the capacitor moved some distance toward the world origin. Repeat this process to create another capacitor that is half the size of the original. Use 0.5 as the scaling factor. Select the 3 solids from the structure tree, then right-click and select Move Each to New Component. Change the name of all 3 components to capacitor, and then add the size at the end of the name. It would suffice to add L, M, or S to differentiate between large, medium, and small. Use the Move tool to place the capacitors anywhere on the circuit board, but avoid the area near the 3 components furthest from the world origin. Select a capacitor from the structure tree, then use the move handles to translate it along the X and Y directions. Click the Anchor button and select the bottom edge of one of the pins. Select the Up To option and click the top surface of the circuit board to snap the capacitor to that position. Repeat this process for the remaining capacitors. Now, we're going to make some changes to the PCB enclosure housing to allow for adequate ventilation. The fastest way to create several duplicates of an item is by using the Pattern tool. The next step is to create a series of holes in one face of the model. Click the tab labeled Views below the structure tree. Then, double-click the view labeled Back. The model should automatically reorient in the window to look at the back face of the enclosure. If we refer to Sheet 3 of the technical drawing in the view labeled Section LL, we can see the dimensions for the placement of the first hole in the pattern. The placement of the first instance in a pattern is the one that's most important. Create a sketch on the back face of the enclosure housing. Start the Circle tool and create a circle with the center point 10 millimeters from either the left or the right edge of the face and 10 millimeters down from the top. Make the diameter 10 millimeters, then start the pull tool. Pull the circular profile in the opposite direction of the yellow arrow to cut a hole. Press S on the keyboard to exit the pull tool. Select the surface on the inside of the hole and start the Fill Pattern tool. In the Options panel on the left side of the window, set the pattern type to Offset and make sure that the hole is selected as the object to pattern. Set the X spacing to 4.5 millimeters, the Y spacing to 5 millimeters, and the margin to 5 millimeters as well. Click any edge of the housing as the direction reference, then click the green check mark to complete the pattern. Many larger consumer electronics generate quite a bit of heat, so some type of cooling solution is often required. Most of the time, this cooling is accomplished by adding some fans to help circulate air over the electronic components. In order to add fans to this design, we need to create a location where the fans can be placed. Examine the isometric view on sheet 3 of the technical drawing. The dimensions for these holes can be found in the view labeled Section FF. Rotate the model to the front view and create a sketch on the front planar face. Place a circle with the center point -45 millimeters from the left edge and 47.5 millimeters from the top edge. Set the diameter to 70 millimeters. Sketch another circle 13.5 millimeters from the top edge and -11 millimeters from the left edge. Set this diameter to 5 millimeters. Create another 70 millimeter circle, but this time use the same dimensions to offset it from the right edge instead of the left. Do the same for the small 5 millimeter circle. Start the pull tool and cut all 4 holes out of the enclosure housing wall. Remember to hold Control to select multiple items. Select one of the small 5 millimeter holes, then click the Circular Pattern tool. Click the edge of the 70 millimeter hole to define the center axis as the axis to pattern about. Make sure the circular count is set to 4 and keep the angle set to 360 degrees so the 4 holes are spaced evenly. Click the green check mark to complete the pattern. Use the Query Select function to select the 5 millimeter hole on the opposite side of the face. You can do this by moving the mouse cursor over the hole and rolling the mouse wheel. If you're using the mouse wheel to zoom, you will need to hold Control while rolling the wheel. Once the hole is highlighted, click to select it. Pick the edge of the 70 millimeter hole again to define the axis, and click the green check mark to complete the pattern. We should now have the 2 70 millimeter holes for the fans and 8 5 millimeter holes where the fans will be mounted. The last items we need to add to this model are the fans themselves. For this exercise, we're only going to focus on creating the housing of the fans and not the fan blades or the motors. The dimensions for the fan housing can be found on sheet 4 of the technical drawing.
The general shape of the fan housing is a square body. We can begin by creating the solid block. We'll need to be clever to create the front and back faces of the fan housing. First, we should create the 4 cutout areas that pass through the entire block. We can then pull a circular profile to remove the material between the front and back faces and create the space required for the fan itself. The next items to add are the rounded corners and mounting holes. Once these have been placed, we'll remove excess material using the shell tool. The last feature will be the chamfer applied to the outer edges of the main cylinder.
Right-click PCB exercise file in the structure tree and select New Component. Name the component Fan. Right-click the new component and select Open Component. Using the default sketch grid created on the XY plane, click the Rectangle Sketch tool and select Define Rectangle from Center. Sketch a square that's 80 mm by 80 mm. Start the Pull tool and extrude the profile 20 mm. Click the Circle Sketch tool and sketch a circle 70 mm in diameter in the center of the front face. Sketch a second concentric circle 30 mm in diameter. Sketch lines from the center point to each corner of the square face. You can double-click at the end of a line segment to begin a new segment elsewhere. Select the Offset Curve tool and enable the option Offset Both Ways. Offset each of the lines by 2.5 mm. The total width between the new offset lines should be 5 mm. Use the Trim Away tool to eliminate all line segments beyond the 70 mm circle and within the 30 mm circle, including the portions of the circle perimeters within the 5 mm offset lines. Refer to Sheet 4 of the technical drawing to see how the fan should look. Pull the 4 profiles all the way through the block to cut the material. Create a sketch plane on the front face of the fan. Then use the Move Grid button to offset the sketch grid -2.5 mm in the Z direction. Sketch a 70 mm circle in the center of the face. Start the Pull tool and pull this circular profile -15 mm. The remaining faces at the front and back of the fan should each be 2.5 mm thick. Create a new sketch on the front face of the fan. Click the Circle Sketch tool and place a 5 mm diameter circle with the center 6 mm from the top edge and 6 mm from the left edge. Pull this circular profile through the entire fan body to cut a hole. Use a circular pattern to place a hole at each corner. Select an edge of the 70 mm hole to define the axis to pattern about. Using the Pull tool, add a 2.5 mm radius to the outside corners of the fan housing. Now that we've defined the primary features of the fan housing, we can perform an operation to remove excess material. For this operation, we'll use the Shell tool. The Shell tool can be used to remove material from within a body. The most basic application of the Shell tool is to create a fully enclosed, hollow body. But the Shell tool can also remove selected faces, providing an opening to the interior of the body. We're going to use the Shell tool to give the fan a uniform thickness and reduce the amount of material required to make the fan housing. We're going to be removing the faces on the top, bottom, left, and right. Click the Shell tool and move the mouse cursor over any part of the fan. Type in 2.5 mm to set the thickness for the shell operation. Now, click each of the side faces on the fan housing. When only 2 faces are left to be removed, make sure to select the radius corner first to remove it. Then remove the final planar face. You should now be able to see the cylinders that define the outside of the holes and the location of the fan. The last feature that remains to be added is the chamfer on the edge of the 70mm hole. Click the Selection tab beneath the structure tree. Then select one of the arc edges on the 70mm hole. The selection tool should present you with several criteria. Click Edges with Same Length. The edges of all 8 arcs should now be selected. Start the Pull tool and select the chamfer option from the Options panel on the left of the window. Enter a value of 2.5 and press Enter. The fan housing is now complete. Close the tab from the bottom of the window to return to the PCB exercise file. The fan should now be present within the larger assembly. Right-click PCB exercise file and select Activate Component. Select the fan in the structure tree and then click Copy and Paste from the toolbar. This creates a duplicate of the component. With one of the fans selected, use the Move tool to reposition it away from the other fan. Click the Assembly tab and use the Align constraint to place the fans in their appropriate positions. Remember that to be fully constrained, a component typically requires 3 assembly constraints. For the fan, you should be able to align the large center hole to the large cutout in the enclosure housing wall, and then align one of the small 5mm holes to its counterpart on the housing. The last constraint should be to make the front face of the fan coincident with the inside face of the enclosure housing wall. Repeat this process for the second fan.
Now that we've finished creating and placing most of the PCB components, we have one final item to add. The processors in this enclosure are going to require additional cooling because they generate a lot of heat. Click the Assembly tab and select the File button. Locate the heatsink and open it. Move the heatsink up some distance in the Z direction to get a better view of it. Hide the PCB enclosure from the structure tree and rotate the model. The heatsink that has been provided for us can be thought of as a generic design. If we look at the underside of the heatsink, we can see that it's just a flat surface. There are no existing cutouts for the CPU components that are already assembled. We'll need to make some modifications in order for the heatsink to fit on this particular circuit board. Fortunately, we have some very useful tools at our disposal. Our approach in this scenario will be to assemble the heatsink in its final location, then use the Combine tool to remove the material that overlaps with the CPUs. Let's get started to see how this is done. Display the PCB enclosure again and go back to the Home view. Select the Align condition from the Assembly tab and zoom in to select one of the holes on the heatsink. Select the corresponding hole on the circuit board and repeat this process for the second hole. Now align the bottom face of the heatsink with the top face of the circuit board. This should move the heatsink into its final location. We're now ready to create the cutouts for the CPUs. Go back to the Design tab and start the Combine tool. Select the heatsink as the target object. In the structure tree, expand the CPU assembly and locate the component labeled CPUs, then select it. Hide the PCB enclosure from the structure tree again and rotate the model to the bottom. With the Combine tool still active and the Select Regions to Remove option active, select the 3 cutouts in the bottom of the heatsink. This will remove the excess material. Click Select to exit the Combine tool, then unhide the PCB enclosure and press H to return to the home view. Once the heatsink has been imported and assembled in its proper location, right-click the heatsink entry in the structure tree and go to Source, use Internal Copy. This will copy the geometry of the heatsink component from the external file and save it with the rest of the assembly in a single file. Congratulations, you've just completed the design of the PCB enclosure.